Today is day 6. We will be looking at various word problems that involve trigonometry, primary trigonometry ratio, or it could involve Pythagorean Theorem. So we use Pythagorean Theorem if we are just looking for a length, but if we are looking for an angle or the length, then we use SOHCAHTOA. So let's try example number 1. Example number 1 is a little bit easier because it gives us a diagram. So a wheelchair ramp is 2.5 meter long. So this is my wheelchair ramp. The horizontal distance from the end of the ramp to the building is 2 meters. What angle does the ramp make with the ground? So it looks like the diagram gives us already a lot of hint. So this is 2.5. This is 2, and they're looking for angle x. What angle does it make it with the ground to the ramp? So because we're looking for an angle, then we gotta write down the formula. SOHCAHTOA. So it looks like this is my starting angle. This is opposite. 2.5 is opposite from my 90 degrees, so this is hypotenuse and adjacent. So it looks like I have to pick a ratio that contains h and a, which is ka. So let's write down the formula. Cosine x, or theta, is equal to adjacent over hypotenuse. And then cosine x is equal to adjacent is 2 over 2.5. Now remember, every time you're looking for an angle, you always have to inverse. So when we move cosine to the other side, cosine become -1, inverse 2 divided by 2.5. Therefore, x is equal to, make sure you put shift and cosine to 2.5. It's gonna get 37 degrees. Okay, so for angle, I would like you guys to round to the whole number, and for the length, round to 1 decimal. And because it's a word problem, you have to end with a sentence. So therefore, angle to the ground is 37 degrees. And that's your final answer. Okay. Now let's try a different type of question. Number 4. So from a point 6.5 meter from the base of the school flagpole, the angle of elevation to the top of the flagpole is 46 degrees. What is the height of the flagpole? Now keep in mind there are 2 terms that I want you to understand. Angle of elevation and angle of depression. Actually, they are exactly the same thing, but just they look different. So angle of elevation is, let's say you're standing over here and there's a bird. So angle of elevation is always horizontal to where you're looking up. This is angle of elevation. Okay, so always remember, it always starts with the horizontal to where you're looking up. Okay. On the other hand, angle of depression is, let's say you're standing on a cliff. Okay, over here. And you see a fish. Unfortunately, the fish and the bird looks the same. So angle of depression, again, is horizontal to where you're looking down. So this is actually angle of depression. So in other words, we are making an upside down triangle like this. So please keep in mind, angle of depression is not this angle. Okay, it's always, again, horizontal to where you're looking down. If you don't like a upside down triangle, what you can do is you could make a triangle at the bottom, right? But using the parallel angle rule, right? Using the alternate angle Z pattern, this could also be angle of depression. But I hope you can notice that angle of elevation and angle of depression look exactly the same. It's always at the bottom to where you're looking up. Okay, so the wording is different, but please keep in mind the angle of depression, you have to be mindful of the horizontal line to where you're looking down. So in this question, we have a flagpole. So let's say a flagpole is over here. And it says this is like from 6.5 meter from the base of the school flagpole. So this is, let's say, 6.5 meter. The angle of elevation to the top of the flagpole is 46. So then from horizontal to where you're looking up to top of the flagpole is 46 degrees. And we made a right angle triangle. And the question is, what is the height of the flagpole? So we're looking for x here. So what we can do now, and we can label. So this is my starting angle, 46. This is opposite. This is hypotenuse, and this is adjacent. So I'm given A, and I'm looking for O. So we need to figure out TOA, which trig ratio contains A and O. It's TOA. So therefore, let's write down the formula. Tangent x is equal to opposite over adjacent. So we're given the angle this time, tangent 46, is equal to opposite, what we're looking for, over 6.5. Now to isolate for x, we're going to move 6.5 to the other side. So it becomes multiplying 6.5 times tangent 46 is equal to x. And then when you evaluate by multiplying, x is 6.7 meter. Okay, again, the length round to 1 decimal. So because it's a word problem, let's end with a sentence. So the question is, what is the height of the flagpole? So the flagpole is 6.7 meter tall. And that is your final answer. Okay. Now let's try something different now. Let's take a look at number 6. It says a flagpole 3 meter tall casts a shadow 5 meter long at the same time that a building nearby casts a shadow 62 meter long. And the question is, how tall is the building? Okay, so keep in mind when something is casting a shadow, the shadow is always at the bottom, right? You see a shadow on the ground. And it looks like we're given 2 different triangles. Triangle 1 involves a flagpole, and then triangle 2 involves a building. So let's start with triangle 1. So a flagpole is 3 meter tall, 3 meter, and it casts a shadow 5 meter long. So shadow is always at the bottom, 5 meter. Okay, and we're making a right angle triangle. Now the second picture is we have a building nearby. Okay, a building, but we don't know how tall it is. That's what we're looking for. How tall the building. And it casts a shadow this time a little bit longer, 62 meter long. And we can make a triangle again. So this time we can't really do Pythagorean Theorem, right? Because we're only given 2 length and no angle is given. So when it involves two triangles, we're going to use a similar triangle, right? So we could say that 3 meter is proportional to x, 5 meter is proportional to 62. So it's like saying a small triangle to a big triangle. So let's write down the ratio. So small triangle is 3 meter over the big triangle is x. And then small triangle, we have 5 meter for the shadow. And the shadow is 62. Now this time what we're going to do, we are going to cross multiply. Criss cross. So x times 5 is 5x. 62 times 3 is 186. And then we're going to divide both sides by whatever it's in front of x, which is 5. Cancel, cancel. Therefore, x, in this case, is equal to 37.2. So, therefore, the building is 37.2 meter tall. And that should be your final answer. So sometimes you will have to use a similar triangle concepts to figure out your unknown length. Okay. Now I do want to go over example 7. So let's take a look at example 7. The angle of depression from the top of a castle to a boat is 25 degrees. If the distance from the top of the castle to the boat is determined to be 100 meter, how high is the castle? So it involves angle of depression where you're looking down. So this is a tricky one. So let's say we have a castle over here. Okay. And we're looking for how high the castle is, which is x. And then from the top of the castle, you are looking down at the boat. So let's say this is a boat here. And it says the angle of depression is 25. Remember, this cannot be angle of depression. Remember that angle of depression is always horizontal to where you're looking down. This is 25 degrees. And then it says from the castle to the boat is 100 meters. So it looks like if I were to make a triangle, this at the bottom is 100 meters. And so using a alternate angle, parallel lines, if this is 25, then this must be 25 degrees, not the top. So now that we understand, we have a right angle triangle. So let's label what we are given. So this is my starting angle. This is opposite. This is adjacent. And this is hypotenuse. So using SOHCAHTOA, I'm looking for O and I'm given A. So it looks like we have to use TOA, tangent. So let's write down the formula. Tangent x is equal to opposite over adjacent. And tangent, we're given the angle 25 degrees is equal to x over 100. Now I'm going to move 100 to the other side. So you're doing 100 times tangent 25 to get x. So therefore, x is equal to 42.3. And so to end with the sentence, how high is the castle? Therefore, the castle is 42.3 meter tall. And that is your final answer. Okay. Now let's try a different one. So I want to take a look at number 10. So it says a 4-meter long ladder is leaning up against the side of a garage. Okay, so we have a ladder and it reaches 3.8 meters up the side of the garage wall. Find the angle of the ladder makes with the ground to the nearest degree. Okay, so let's say we have a garage over here and the ladder is leaning against the garage. So this is my ladder. Okay, this is my ladder over here. And the ladder is 4 meters long. And it reaches up 3.8 meters tall. So this is 3.8 meters tall, up on the garage wall. And the question is asking, find the angle the ladder makes with the ground. So this is the ground over here at the bottom. So we're looking for this angle, x. So it looks like we have a right angle triangle again. So let's label what we're given. So this is my starting angle. This is opposite. This is hypotenuse. And this is adjacent. Using SOHCAHTOA, I'm given O and I'm given H. So using the 3, I can use sine, because those two are the given information and we're looking for an angle. So sine x is equal to opposite over hypotenuse. So sine x is equal to 3.8 over 4. So to isolate for x, I'm going to move sine to the other side. So every time you're looking for an angle, the trig ratio become reciprocal, -1, 3.8 divided by 4. So punch it in your calculator, second or shift or second function sine, don't forget the bracket, x, you should be getting 72 degrees. So therefore, you can state that the ladder makes 72 degrees with the ground. And that is your final answer. So I think that the most difficult part is just getting the diagram correct and then figuring out if you have to use a similar triangle or SOHCAHTOA. Okay. Now lastly, I want to go over number 11. Maureen is making a pen in her backyard for her daughter's pet rabbits. She makes the pen in the shape of a right triangle. Now 2 sides of the pen each measures 3 meters. What is the length of the third side? Okay, so it looks like, so she's making a pen and it makes a right angle triangle. So right angle triangle. So 2 sides of the pen over here, it would be 3 meters, 3 and 3. And this is the third side, x. So therefore, so in this case, we can use, I think it's better to use a Pythagorean theorem because we're only working with the length and we're given 2 sides. So we don't need to use SOHCAHTOA. So let's write down the formula for Pythagorean theorem. A squared plus b squared equals c squared. And we're given the leg of each, a and b. And we're looking for c, which is the hypotenuse, the longest length. So I'm going to plug in 3 squared plus 3 squared is equal to x squared, or c squared. So 3 squared is 9 plus 9 equals x squared. 18 equals x squared. Now opposite of squaring is we got to square root both sides. And once you square root it, x is equal to about 4.2. So as you can see, the hypotenuse is definitely longer than each leg. So we are doing it correct. So therefore, the third length is 4.2 meter long. And make sure you end with complete sentences for each word problem.